section 8.5, page 126, 127, 128 deals with nets. Okay, imagine you've got a shoebox. You cut skillfully down the edges and you spread it all out. What would you see? Well, you will see a net of the shape. Then you put it all back together again, put sellotape down the edges, stick it down, you've got your shoebox back. Essentially that's what a net is. And what I've got there is a representation of question 6, because the rest of what they've got in there is absolute rubbish. So question 6, the diagram shows a square based pyramid. Why is it square based? Because that is a square on the bottom. That by that is a square. Doesn't look like it, that looks shorter. Well, that's the nature of perspective for you. Anyway, so that by that is a square, and it comes to a point, hence it's a pyramid. Now it has a square base, yes, thank you, and 4 identical isosceles triangles as faces. So I've got a square bottom, and that's an isosceles triangle. That's another one. That's one at the back. I've got this one here, which it's hard to see. So 4 isosceles triangles. Now Max drew this net for the square base pyramid. Alright, well I can see the square base. What is wrong with its net, with this net even? Well look, if I try and fold the card right there, I can flip this inwards and go like that. I can flip this one inwards and do that, flip this one inwards and do that, and this one inwards, and it will meet. Trouble is, they will meet flat on the floor. They will not produce a pyramid shape because the isosceles triangle lengths here and here, here and here, here and here, and here and here are simply not long enough for them to meet at a point above the square base. Do you see? It will fold it all in like a flat, almost like an envelope type thing, a square envelope, but it will not reach a point in the pyramid. So I'm going to rub that out. So that's what's wrong with it. So let's get rid of that quickly. And then it says draw a net that does make a square base pyramid. Well, what I'm going to do is use this ready-made one and draw over it. So if I use my pen facility, if I make sure it goes to here and then to here, I've got a longer isosceles, I have a taller isosceles triangle with a bigger height. If that's the case, then when they meet together, the point will meet somewhere there, but you know, elevated towards us as if it's popping out the screen. Alright, so there to there, and there to there, there to there. I'm glad they gave us this space. There you go. So essentially, if you ignore Max's black outline there and look at my red one, when I try and push this corner, this vertex back in and fold it in, it will meet at a point somewhere directly above. If actually it will meet like that, won't it? It won't be very tall. If I'd come out an awful lot more, like that for example, there will be a much taller square base pyramid. But essentially, these are straight lines. They'll just fold straight in and fall on the floor. So what's wrong with this net? The vertices shown from the top of the isosceles triangles will not meet at a point above the square base. But since I've made it longer now, I now have a valid net for a square base pyramid. Let's look at the next question on the other page, and this is question 7. This is Mike having a go. Now Mike uses card to make a gift box for his mum. It's her birthday and he's going to put the present inside the box as shown. Draw an accurate net of the gift box on squared paper. Well, I'm going to use a squared paper here on the screen. Now it might help if I do this first. I know that's 4, so this is like going to be like that, isn't it? Sort of like that. And this will join like that. And I've got this triangular part like that. Do you see? You can see how lovely in 3D it is now. It's not brilliant, but you know, I'm working with a graphics pen on a graphics pad and nothing's perfect. Essentially, you can see therefore I've got one face on the bottom, this rectangular face here, a triangular face there, a triangular face here, and this rectangular face. I've got 1, 2, 3, 5 faces. So my net will have 5 faces, 3 of which are rectangular and 2 of which are right angled triangles. Well, that's a right angle, and that's going to have to be a right angle as well. So I've got to represent that. Let me start with the 4x6 bottom part. Alright, let's work in blue. 4x6. Let's take a good look and be very careful. 1, 2, 3, 4, 5. How many is that? 1, 2, 3, 4, 5, 6. That's that. and it goes 4 across, so I can go 4 across like that and know that it's good. Right, that's the bottom bit. There's several ways you can do this. I'll just stick to one way. So that's my 4x6 bottom. Now if I bust this open and let this flip over to here, I'm going to be 3 centimeters high but flipped over. So I'm going to add my 3 centimeters onto here and go 1, 2, 3, 1, 2, 3, and then just join the ends. Alright, so this part is actually this part flipping over. On the other side I've got a slant of 5, but it still goes back 6 centimeters. So I'm now going to do a 5 here. So 1, 2, 3, 4, 5. 1, 2, 5. Just drag it and drop it, and join the ends. I'll put the measurements on in a minute. Now what must? Oops, make it a little bit longer. Good enough. Now I haven't got a triangle yet, have I? Right. I now need to do the triangular parts. So let's have a look. That's 3. That's 4. That's 5. So I must get a lovely 5. In order for the triangle to match this 5-sided, this length here, not 5-sided, it's 5 length, I must go 5 down like that. So that will match onto that, and I think that's alright. Or is it? Let's just think very carefully. It's quite tough, this. That's the longest side. No, it's wrong. Let's just rub that bit out if I can. I think I'll use this actually to ditch that. Yeah, get rid of that immediately. Delete. It's gone. Let's think again. It's quite hard, this actually. Right, do it this way. 3 centimeters tall. 1, 2, 3. Yeah, got it. So from there to there is going to be 3, and join the ends. That's it, and that will make an automatic 5. Yep. I've got my 4 stuck to the 4, my 3 stuck to the 3, and that will become 5 automatically. So I do it on the other side as well. Why not? 3 up, 4 across, and the ends joined makes 5. Now let me just label it carefully. Obviously I made a mistake. I'm thinking, you know, on my feet here. So this is going to be 5 centimeters. That's going to be 5 centimeters. That is 3 centimeters. So I've got like 5 and the 3 and the 4 centimeters there. So that represents that triangular face there. Same at the bottom. I've got a 4 centimeter. I've got 3 centimeter and a 5 centimeter longest part here. That is also 3 centimeters. Of course, the whole prism goes back 6 centimeters. So that's 6 centimeters. This is also going to be 6 centimeters. Obviously, that's 5. It's a rectangle. Obviously, that is 3 because it's part of the same rectangle. These lengths are all 6s, as is that one. And that's fully loaded, I believe. So there's my accurate net eventually. What is the area of the card Mike uses? Alright, I called it a prism, by the way. It is a triangular prism, just in case anyone asks you. So here we go. Triangular prism. Alright, there you go, that's what that's called. Toblerone, basically. Right, area of the card. I have got 1, 2, 3 rectangles and 1, 2 triangles. Got to work out each area and add it up. Okay, I've got a 6 by 5. Let's do it here quickly. 6 by 5. Well, that comes to 30 centimeter squares. That's that one done. I've got a 6 by 4. Well, that's 24 centimeter squares. So that's that one done. I've got a 3 by 6. Or 6 by 3. So it looks all nice. That's 18 centimeters squares. Is that done? Well, each of these triangles is half base times height, so half times 4 times 3, but I've got 2 of them. It's almost as though I can take this one off and stick it right there. Alright, so the 2 halves make a whole, and what do you see? I can see a 3 by 4 rectangle. Right, this dotted line is not part of the net, obviously, but I'm just showing you that I could snip that off there and whack it there. Not a net, but it's a rectangle. So I'll just say 4 times 3 and get on with it. 4 times 3, that'll give us 12 centimeter squares. And this is now the total surface area. And that's going to be 34, 54, 54 plus 30 is going to be 84 centimetre squares of area. That's how much card we need to make that triangular prism Mike's mum's birthday present box. And I think I'm going to stop there, and that'll be fine. And that is Nets